Hi, today we are going to learn how to create ASP.NET MVC Core Web API using .NET Core 3.1 and how do we deploy that to Azure App Service API app. So overall, what we are going to learn today is how do we build ASP.NET MVC Core Web API using .NET Core 3.1. How do we create open API documentation for the API using Swagger framework? How do we test the API with the help of Swagger UI? How do we create the Azure App Service API app? And how do we deploy ASP.NET MVC Core Web API to Azure App Service API app? Let's begin. For this, we'll need to use Visual Studio 2019. And here we go with Visual Studio 2019. This is how your welcome page looks like for Visual Studio 2019, where we'll be taking create a new project option. There we will be searching for the ASP.NET Core Web application, for which we can make use of the filters drop downs that are available here, where I have selected C# as my language, all platforms to be targeted. So cross-platform implementation I'm looking for. And here the type of application that I'm looking to create is web application and selected web. In the filtered list, the first option shows me as ASP.NET Core Web Application. That's what I'll be selecting here and click Next. Let's give the name to this particular project, named as DNC underscore demo web API. With Swagger. That's my location. Click Create. Here we will select the template named as API that allows us to get some sample web API created on the target framework as .NET Core with the version as 3.1, just confirmed over here. Make sure configure for HTTPS checkbox is selected here and click on create. Once the project is created, you get this welcome page over here that can be closed. And let's go to Solution Explorer and have a look at what we have got by default. We have got a model class named as weatherforecast.cs by default that represents the data that is going to be represented and handled by our web API named as weather forecast. And what this weather forecast model class contains is a field named as date of type date time, representing the date of the weather forecast being shared. Then we have temperature in Celsius with the property name as temperature C, representing an integer. Then we have temperature in Fahrenheit represented by the property temperature F with the calculation based on the temperature C. It will get the temperature in Fahrenheit automatically calculated. And then we have a field named as summary showing up the details about what kind of weather it is based on the temperature. So if it is too hot or too cold or chill, fizzy or whatever it is. Then we have our controller, weather forecast controller. This class weather forecast controller now represents my web API that inherits from controller base and has got an attribute as API controller, making it a RESTful web API here. The route over here by default takes in the controller as the route parameter. As per the convention, we will just make a small change over here to include API/ before the controller name. Then this class has got a read-only array definition named as summaries, which represents the different values that will be put into the summaries based on what type of temperature it is. Then for the logging purpose, we already have a logger by default being dependency injected here, which can be optionally used in case if you are looking to do some kind of logging. So here we go and put our first statement into this get method as underscore logger dot log information with some message. message looks like get weather forecast invoked at time dot now. To make this datetime dot now show up the actual datetime value, I need to prefix the string with dollar for string interpolation, and hence this value is going to be taken instead of displaying curly brace datetime dot now displayed as it is. And then we have some logic over here to get different weather forecast data generated for next 5 days. Or if you want it for 7 days, we can make a small change over here. In the range method, instead of 5, I put 7. So it shows up the weather forecast details for next 7 days. And the list is going to be returned over here by this web API whenever it is called. The next thing that we need to do is to add the open API documentation for this web API so that my end users can understand what this API has got to offer, what all operations are there, what input goes in, and what kind of output is expected from this API. And I want this documentation to be shared with my end users. For that reason, we have multiple frameworks available which can help us generating the open API specification. Out of which the most popular one is Swagger, and that's what we are going to use. With one of the NuGet package, we will be getting the feature installed into our project. So let's go to Package Manager console window, and here we'll issue the command install package .ASP.NET Core and press the enter key on your keyboard. So this installs your Swashbuckle package along with all its dependencies. And the next thing that we would need is to go to your startup.cs file, which contains all the configuration about your project, about your dependencies, and about what are the middleware components that are going to be loaded by ASP.NET MVC Core framework. So if I talk about the dependencies, all dependencies are registered with the help of the configure services method, where all the dependencies are represented by a service collection instance. And then the middleware components are loaded with the help of the configure method, where you have this iApplication Builder object that allows you to inject whichever the middleware component you want to use with your application. Now here, first of all, I need to put the using statement that imports the namespace representing our Swashbuckle Swagger framework. So here, the name of that namespace is Microsoft.OpenAPI.models. And then we need to first of all register the Swashbuckle as a dependency. With the help of configure services method, we will get this dependency registered, where we are going to use this services object, which is of type iServiceCollection, and its member method named as add_swagger_gen. That stands for add swagger generator. This method takes in a parameter of type action, which is a delegate. And for delegates, usually these days we make use of the Lambda expressions to make the overall implementation simpler. Here we go and put a parameter name that is options, that goes in options, which is of type swagger_gen options, swagger doc. It takes in a couple of parameters, the name of the document, and followed by the Open API info instance. Name I'll put as V1, that represents version 1, followed by comma, followed by the new instance of Open API info, where the open API info allows me to put some details like the developer's contact details, the description about this API, the license information, the terms of service information, the title for this API, and the version for this API. So for now, I'm going to use a couple of properties from here using object initializer. I'll set that. Let's say the title is the first property where I say this is sample API, because this configuration is going to be the project level. Any API that you have created into your project will be exposed via this Swagger generator to your clients. It's not just one API that is going to be exposed. Version, let's say, is V1. That corresponds to what we have specified here. Next thing that we need is to utilize this particular injected dependency somewhere. Otherwise, this injected dependency is never going to be invoked and our Swagger documentation is not going to be generated. So for that, we will make use of the configure method where we'll be using a middleware component that actually consumes that web API. So here we say app.use Swagger, which is like using the Swagger middleware that then ultimately makes use of the Swagger generator service from the injected dependencies. Now, this is going to be generating the JSON documentation that represents open API specification for my web API straight away. Let's test this out. Before that, one small change we will be making here into launch settings.json file that is available into properties. So let's double click and open it, where the launch URL is something that we are going to change here, as we have included some additional stuff into our route template that looks like API/controller name. By default, it was looking for the default route only. That's why directly it was looking for weather forecast. But because of our change, now this is something which we'll need here and here also, if we are going to host our web API on a self-hosted environment, not IS Express. Let's save this and press Ctrl F5 to execute your application. This should launch the browser in a short while. And I should be able to see some details on the browser, because this request has automatically put a GET request to make a call to weather forecast API. Now I'm interested in looking at the open API's documentation for my API. For that, I just remove the route entirely, just the base address of the website I keep over there. And after that, I put /swagger/swagger.json. That's the default path used by the Swagger generator. And this V1 will depend on what you have given in the configuration. So here comes the JSON documentation representing all the metadata of your web API, which needs to be shared with your prospective clients who are looking to consume your web API, where they can understand what is the endpoint information, what is the input that we are supposed to give, what is the output that we are going to get if we make the call to this web API. All the details going in over here, pretty similar to what the WSDL documentation used to do for the standard HTTP web services based on SOAP. But now we can see that this is not very useful, or this is not very user friendly. My downstream developers might find it difficult to understand this JSON documentation, as they may not have experience with JSON, or they may have very less experience with JSON. So the next task that we have over here in hand is to use some kind of tool that reads this documentation and generates some user-friendly UI for my end users, where instead of reading this documentation, they would be able to use the UI itself to understand what all this API is about, what all inputs are there, what all outputs are there. If they want, they can dirty their hands with some sample information as well. So let's close the browser and back into the Visual Studio. We'll go to startup.cs file, where one more middleware component will be adding now that looks like app.useSwagger.ui. This is an extension to the previous middleware that we have added. Without the previous middleware, Swagger UI is not going to work for us. Swagger UI, this also takes in action delegate, and that is taking in the parameter of type Swagger UI options. And I'll make use of the Lambda expression where I say the parameter options goes in options dot Swagger endpoint. Here I need to give the path of that JSON document where my Swagger JSON is present. So what we put in the browser after the base address is the same thing we'll be putting over here. Put /Swagger /v1 /swagger.json, exactly the same path that we gave after the base address in the browser to read that JSON document. And then here we need to give some name to this particular document. And I'm through to my subscription. Let's close this recommendation page. The first thing which I'm going to do here is create a new resource group wherein my demo API app can be hosted. For more details on resource groups, you can visit Azure documentation. I'll just go to resource group, click on add, give the name to this resource group. That's my subscription. This is also important because you may have more than one subscriptions into the same account or mapped to the same account. So carefully select which particular subscription you want to create your Azure API app into, and then give the resource group name. I'll call this as demo RG. Region, you can select as per your need, and your UI for the API gets generated. Here, I can see my API weather forecast is already there, whose endpoint is available here. And if I want to test this out, I just need to click on get. After that, I need to click on try it out, where if any parameters are requested by this API, the UI will be generated to get the values of parameters inputted. And after that, you just need to say execute. So your API gets executed, and here you get the formatted JSON response, and the response headers also getting displayed. Port 200 description success, saying that the request was successful, there was no error. And then it is also showing me the example value over here, what kind of data I can expect here. Then at the bottom section, I have something titled as schemas, where I can see one of the schema getting displayed as weather forecast, which is actually our model object. If I expand this, it actually shows me the JSON representation of that schema. Date, string date time, temperature C integer, temperature F integer. This is read only as well. And then we have summary, which is string, and nullable is true for this. So our Swagger documentation is successfully generated. We have used that Swagger documentation to test our web API as well. The functional test I'm talking about. Next task over here is how do we create Azure App Service API app to get our web API hosted on Azure App Service API. So let's proceed to the browser. Here, first of all, we need to browse to portal.azure.com. What that means is you need an active Azure subscription, and I'm through to my subscription. Let's close this recommendation page. The first thing which I'm going to do here is create a new resource group wherein my demo API app can be hosted. For more details on resource groups, you can visit Azure documentation. I'll just go to resource group, click on add, give the name to this resource group. That's my subscription. This is also important because you may have more than one subscriptions into the same account or mapped to the same account. So carefully select which particular subscription you want to create your Azure API app into, and then give the resource group name. I'll call this as demo RG. Region, you can select as per your need. I'll select the region as Southeast Asia. So it can be anything based on where your audience actually is present. Next. Click on next again and click on create. A resource group gets created here. I can just click on go to resource group and it's here. If I want to add any resources here, I can directly say add from here itself, or else I can directly make use of the main menu where I can say click on create a resource. What I'm looking for is a Azure App Service, which is available in the category web. There we have to search for API app. So we'll use the search box and put the search string as API app. It comes up over here, just select that. And there it gives you the selection for API app. Click on create here. We need to name this API app, which will become a subdomain into Azure websites.net. That is an existing domain. Let me name this as sample APIs and see if it is available. This needs to be globally unique as this becomes a globally accessible domain, subdomain. The green tick mark over here shows me that it's available. This is my subscription, and then resource group. I can create a new one or I can use existing. As we have already created a resource group, I'll select use existing. And from the drop down, I'll select demo RG. That was the resource group we created in the previous step. Then comes the app service plan, which decides what kind of machine configuration is required to host this application, whether I'm going to host this API app in a shared hosting space or I'm going for virtual private hosting. In case of virtual private hosting, what is the virtual machine configuration that I would be looking for? All that is decided by the app service plan that you select here. So let's click here and select create new. Name this app service plan. I'll call this as demo plan. Location should be same as your resource group. Whatever you selected for resource group, the same location you have to select here as well. So I'll select Southeast Asia, and then comes the pricing tier. We have different categories: dev test, production, isolated, different configurations represented by these. But now we are actually looking to develop a web API and test it. So I'll go to dev test category, and there, because it's just a demo sample web API, I don't need to have a dedicated virtual private hosting environment. So I just go for the shared infrastructure that doesn't charge me anything. It's a free infrastructure with 1 GB of memory and 60 minutes per day compute I'm presented with. While developing the web APIs, this is going to be good enough. And later on, if you want, you can scale it up. So let's select F1, shared infrastructure, and click on apply. And click OK. For application level logging, now Azure gives us the cloud scale logging infrastructure by the name App Insights or Application Insights. By default, it makes it available for all the app services that you deploy. Here, I'm not looking to use that App Insights for now for my web API application. Hence, I click on this option, App Insights, Application Insights, and here I click on Disable and Apply. And then click on Create. This will take some time to get the deployment done. By the deployment, I don't mean that we have deployed our our Azure API app service with the web API that we have created in Visual Studio. Here, we have just created a reservation for a domain or the hosting space wherein our API is going to be further deployed. If I click on go to resource here after the deployment succeeds, it gives me some URL. If I click on this, it will just show me some sample page as of now, saying that your reservation has been done and now you can start deploying your application. So I'll keep this URL as it is. And let's go back to Visual Studio. Go to Solution Explorer here. Select your project. Right click the project and click on Publish. App service is what we are looking for. So our first selection on the left hand side is perfect. Here we have two options, whether we want to create a new app service or select existing. As we have already created the app service on Azure portal, we'll be going with select existing. Then click on advanced link. Here you have to set some publish options, like in what configuration your application needs to be published. If you are just developing and testing the application as of now, you may want the debug mode to be published. If you are done with the development and testing, probably then release mode is what you will need. So for now, I'll just go with release, assuming everything is done. Target framework, it has automatically detected as Netcore App 3.1. Then deployment mode is something which basically provides me two options, framework dependent and self-contained. Framework dependent means I assume that where I'm deploying my application, that environment already has got .NET Core 3.1 runtime installed onto it. And as the part of the deployment, I'll be deploying only my application. Whereas self-contained means whether my target environment, host environment has got .NET Core 3.1 runtime environment installed or not, my application will carry its own copy of .NET Core 3.1 runtime environment as a private copy and will get itself executed without any issues, as it will have its own copy already there. So even if there is no framework runtime deployed or installed on the target environment, the application is not going to fail at all. So for now, we'll say framework dependent. And then the runtime, we have to select whether it is going to be portable or some platform specific. On cloud, it's better you keep it portable. Then go to file publish options and say remove additional files at destination, so that that sample page also will be removed. We are not using any database in this API, so by default it says no database is found in the project. Great, click on save. Click on create profile now. In this step, I'm supposed to connect to my Microsoft account, which basically holds a active subscription for the Azure services. As my Visual Studio is already logged in the same account, automatically it finds out my subscription. If not, we can actually use this add an account option to log in with the correct account information that holds your active subscription. So here I see I have two subscriptions on this account, from which I'm going to select this Visual Studio Enterprise. And then here it shows me all the resource groups that are deployed on my subscription. We created one that is demo RG. I'll just expand this. And here I get to see the deployment which we did before coming to Visual Studio. So sample APIs I can select there and click on OK. So your profile gets created. By profile, what do we mean is all the details that are required for the successful deployment of this application, including where to deploy, the user IDs, the passwords that are required to connect to this URL and initiate the deployment. All that configuration is downloaded at the application level. And that is what we call as profile, which you can actually see over here. In Solution Explorer, you go to Properties. Under that, now you can see there is a new folder coming in, Publish Profiles. If you expand this, there is a pub XML file which contains all this configuration. If I open this, it shows you all the details here. And this can be reused whenever I make some changes to my application. I need to redeploy it. So this profile is going to help me out to get it quickly redeployed. So once this is done, I just click on Publish to initiate the deployment. We need to wait for publish succeeded message in the bottom left corner of Visual Studio window. And in fact, it by default launches your browser also. This is perfectly okay. This is not an error actually, because our API is at a different path. Here we'll say /API/ weather forecast. And our API is available. And the moment I put Swagger over here, I get the Swagger documentation UI as well. One requirement over here could be at the base URL itself, the Swagger UI, if it comes, it will be great for me. So for that, we need to make some change into our Visual Studio code. And here we go to Visual Studio, startup.cs. And this implementation, we will require to be changed a bit to make the Swagger documentation visible directly when I'm landing on the base URL itself. So I just get this statement selected and cut from here. I put curly braces pair. I need a multi-line statement, hence curly braces would be needed. I paste that statement back, end with semicolon, and put one additional statement over here that sets route prefix property for the options object to string.empty. So this will make sure that my Swagger UI gets visible at the base URL itself. We can test this out locally first of all before deploying it. So just say Control F5. And let me go to the base URL. So it is directly showing me the Swagger documentation. Let's close this and let's go back to Visual Studio and repeat the publish process because we have made some changes to the code. Redeployment is needed. I just right click on the project and say publish, publish. It will detect whatever changes are there and will deploy only the changed components. The deployment will be a little faster this time. And done. Even you can refresh over here as well, the page that we opened earlier, and both of them are showing me Swagger UI. I can test this out, whether after deployment also it is giving me the same output or not. Let's click on try it out and say execute, and I get the response. So post deployment also my web API is giving me the response into Swagger UI, and I'm able to see all the other details as well, including the schemas that are used by my web API. One last thing that we will do over here to conclude this session is we have a link over here that takes me to the JSON documentation. Let's click on this link. Just below the title, we have that link. And once this JSON document is visible here, just get this document saved onto your desktop. So by default, save options these days are not provided by the browsers. No issues. We'll just select all the stuff by using Control A keyboard shortcut. I select this and then say right click, copy, open Notepad. In the new window, I'll just paste that content and get it saved from here. I'll put it on my desktop by the name weather forecast, or maybe just sample APIs .json. Sample APIs I'll name as sample API spec.json, as it contains all the specification about the API. Save and close this document. This is something that we will require in our next session, where we are going to see how this API can be productized with the help of Azure API management. So that's it for this session. Thanks. See you in the next session for Azure API management.